we're discussing chemical reactions, there's products, there's reactants, and there's some equilibrium point where there's equal numbers of products and reactants being made at the same time. But how do we know when the reaction's in equilibrium? How do we know the reaction's even occurring in the first place? Where is this reaction occurring at all? To better understand this, let's explore thermodynamics. Since everyone's got one, let's use the human body as an example. The reason ATP is so important is because that phosphate bond, it's a really high energy bond. All of the energy that was in that bond is being released into the system and contribute to some other chemical reaction and increase the likelihood of other reactions occurring because they need more energy. When the energy from the ATP bond is transferred to another reaction, all of that energy is not necessarily going to make the reaction occur or do some work. Some of it also might just be released as heat. So the sum of all of that energy from the ATP molecule is a combination of the work that's being done in that chemical reaction and any heat that's let off. But what are heat and work? First, let's talk about heat. Heat and temperature are two people who are trying to dismantle their paternalistic ideals. They want to be in a relationship with each other, but they recognize that they have to define what a relationship means for themselves. Heat has a tendency to get a little jealous when heat and temperature are in situations with other attractive people, but heat recognizes they can't prevent temperature from being in the public ever. After some self-reflection, heat realizes three things. 1, the number of people does matter, no matter how attractive they are. 2, their attractiveness does matter. There's a level of tolerance depending on how attractive the person is. And 3, temperature's behavior does matter. The more that heat sees temperature changing the way they're acting, the more heat is likely to get upset and react in a jealous manner. After doing all of this self-reflection, heat is ready to go and have a calm, mature, productive conversation with temperature about their feelings. They recognize the need to keep things simple for temperature, so they make up an equation. Q is themselves, and it is equal to mc delta T, where m is the number of people, C is the attractiveness of the people, and the change in temperature is how much temperature's behavior is changing as it relates to chemistry. Q is heat, and that's equal to m, the mass, times C, the heat capacitance, times delta T, which is the change in temperature, in Kelvin. So heat capacity is how much heat one specific molecule is able to absorb without a change in temperature. Every single molecule is going to have different heat capacities, and that's going to change how much of a resistance to temperature change each molecule is going to have. Work and volume are also trying to define their relationship, except their relationship has to do with parenting duties. Work feels a lot of pressure from all different sides and feels that if volume was able to come in and help a little bit more, work would be able to do a little bit more as well. Not saying that the pressure is going to be reduced at all, but it is to say that any change in volume's behavior is going to be helpful for work to get more done. Work is equal to pressure times a change in volume. However, they also recognize that sometimes networking is necessary in order to make the business run. So they acknowledge and arrange that there's going to be times where work is taking its energy away from the business and giving it to some type of networking event or something else. When the amount of work that's being taken from one system and transferred to another system is a removal of energy, the sum of the energy that's still left in the system or still left in the business is the amount of energy that heat is putting in minus however much energy work is having to divert to networking or other things. Or if you're comparing two systems, the energy in one system is equal to the heat in the system minus the work that that system is doing on another system. In summary, the total sum of energy in an internal system or just one system where there's not work being done somewhere else is equal to the sum of the heat plus the work, or Q plus W. If we're talking about this energy in a universe where there's multiple systems occurring, we can talk about the sum of the energy in that universe is equal to the amount of heat that is existent in that universe minus the work that that universe is doing on something else. Heat is equal to mc delta T, or mass times heat capacitance times change in temperature. Work is equal to pressure times the change in volume. Then we can also say that the sum of the energy in the universe is equal to mc delta T minus heat delta V.